So we are starting, and let's start with a new project. We'll be talking about game development. We'll use SpriteKit today. So let's create new Xcode project. And of course, game. And that's our start. Let's call it my first game. Make sure that the language that you use is Swift and the game technology is SpriteKit, because you have other options here. You have SceneKit, you have OpenGL, and you have Metal. SceneKit is the package that allows you to build 3D games. SpriteKit is for 2D games. OpenGL is OpenGL, right? You can do both, but it's also meant more for 3D games. Metal is more advanced package for gaming. So let's go with SpriteKit. We want to go with iPhone. Don't want to include anything else. Next, and save. Okay, let's look at the structure of the project. What do we see here? See that the structure is very similar to what we have in UIKit, right? There are two new components. First one is SKS file, and this is a graphical way to build a scene. Interesting thing is that you can have more than one SKS file, and well, one scene can use more than one SKS file. You can use them kind of like layouts. So for example, when you're building an infinite runner game or type of, you can use SKS files, many of them, to build different layouts that you will, alternate to have more random layouts for your player, right? In general, you can drag and drop different components here. You have list of different elements in the toolbox, right? Starting from from simple nodes, color sprite, empty node, some lights, emitters, labels, shape nodes, and so on, right? And the second new component is a class called game scene. If you remember something from the lecture, you would remember that in SpriteKit, we operate with game scenes. Those are like bigger components, like your start scene, start screen in your game, and level 1, level 2, and so on. You can divide it into scenes, and you can load them. All of them will inherit SK scene, so SpriteKit scene, and they will contain the gameplay, the game logic. They're loaded by game view controller. This is something that is coming from UIKit. It's UI view controller. It contains or it loads one scene, and the scene is loaded by very specific view. This view is in the storyboard. So if we go to the main storyboard, you will see that we have this view here. We check who's that. This view is SK view, so SpriteKit view. And really, everything happens, most of the things happens within the game game scene that is presented by the view. And you will see that view controller is useful in some cases. For example, you want to play the background music. No matter which scene you're showing, you want to play the same music all the time, right? Then you would use the game view controller to do it. Other things that are specific to concrete state of your game, you will do in the game scene. Now, when you start your project, there is some code. What this code is doing, you can run your game and you can check. It's basically a sample of few functionalities that you can implement using Sprite Kit. Let's make it smaller. So first, it loads the scene, the hello world. This is the label node. Now, if you tap, you see that the planes are added and they are rotated. How it happens? It's really this code. This code is good for learning if you think about it. See, hide inspector and hide debug area. Okay, now we can see something. You have two functions, well, three functions, but one is empty. You have two functions in the game scene. First one, did move to view. This function is executed when your scene is displayed. So when view is calling function present scene, this function is called. And what happens in this function, we're adding the node. So we're adding new element. We're creating first new element, the label, setting the font that we want to use and the text that we want to use, size, and position. When the node is configured, we're adding it as a child to the scene, right? And that's the hello world text in the background. And you can play with different values here and see how it affects the final effect that you see on the screen. The second function is something that you already know. You've seen it. Touch is begun. What is this function doing? It's a reaction to the touch event, right? And what it is really doing, it is finding where the node was touched. So it's finding the touch.location in node, and then it is creating a new sprite ship. This time, the type of the node is different. It's SK sprite node. And sprite node is used to display different kinds of images. Right? We are adding this node, making sure that the scale is set in the way that we want. Now we can play with the scale. Right now, we are scaling it up or down. Scale is 0.5. Which means, yes, we are making it smaller, right? We're setting a new location, and location is the location of the touch event. And we are doing something more. We create action. What is the action? Action is rotate by angle. We're saying that this sprite that will be playing this action will rotate by given angle, and the angle is pi. Within 1 second. And then we are telling the sprite to run action and to repeat this action forever. Right? So that's why they're rotating all the time. If we remove this, play forever part, what will happen? We'll add the plane, we'll rotate, and then stop. And And again, at the end, the sprite is added to the scene as a child element. What you see here is that everything here happens in the code. If you check SKS file, this file is empty. There's nothing there. It's a gray field. You can add components here. But in the beginning, what we'll be doing, we'll be using only a Swift code in our games. The last function that is in our file is update function. This function is called after or before each frame is rendered, right? So in each frame, we have one call to update function. And again, this is not new. I told you that during the lecture, right? Same concepts that we learned in Unity course will apply here, right? So we have a game loop that is going through rendering and updating. Plus, we have some events. The same way we had events in Unity, right? When two objects were colliding, we had a function that was executed. We have similar concepts here. So the first thing that we'll do will be changing a little bit this this code. First, you can modify the code that you have here to display the text that you want, not necessarily the hello world. The font that you want, the Chalk Duster font is in your project. It's the one of the fonts from the library. You can check documentation and see what other fonts you can use. The image that we are using is in assets, spaceship. It's here. If you want to use different images, so for example, I want to use my car, I will just drag and drop them. I have the car on the desktop. I will drag and drop them to my assets, and new components, new elements are automatically created. Right, so I've added car. I will rename it car. Track with uppercase T, so I'm consistent with naming. Now I have only the first image because I'm creating a game for iPhone. If you want to go with universal, if you want to create a game that works on iPads, you should add images with proper resolution for bigger screens, right? So for regular iPad and iPad with the Retina display, you should add ×2 and ×3. Adding them here allows me to use the function that you see in the code here when we create node, and just use image named. You can also add images directly to your project structure, then simply you will have to provide the full name here with the extension when you create a sprite node. Okay. So let's say right now we want to add only one node. We don't want to add those spaceships when we tap, right? We don't want to do that. We want to add one, it's our player, and then we want to move it to the location of the tab, right? So let's remove the code, or basically we can copy this sprite, and with the action, let's cat it from touches began, because we want to set it up in the beginning of our game, right? So the first thing that will show up will be our spaceship, or you can replace it with a car if you want. The question that we have to answer is, where should it be placed? Right, so we have to create the location. And if you remember the location, the position of the node is a CG point, right? So I'm replacing this. I should create a CG point. And I have to say exactly where my spaceship should appear. Where? Well, I have different. Sorry, I have different options. Again, I will go back for a minute. Here, using self frame, cgrec get meet x. This function allows me to place it directly in the center of the screen, right? So let's do it this way. This will be sprite, and this will be sprite. I will move it here. Right, so I'm creating a sprite node for the spaceship. I'm scaling it down. I can even scale it farther, right? So let's say 0.3. We don't need that big ship. I want something smaller. And I will place it originally, I will place it in the middle of the screen. It will rotate, and then we'll add our guy. So now if I play this game, I have my spaceship ready. Now you can move it up, changing the value here, by changing the Y position. Do you remember where is 0, 0? So what do I have to do to move it up? Yeah, so if I want to move it up by 20, plus 20. It's higher, right? Now, to modify this guy, I cannot simply create it and add it to the scene. I should have variable space cheek. That is sk node. And I will assign it right here, right? So spaceship will be equal to sprite. Or I can, instead of using sprite, right, this one, I can simply use my spaceship. And then replace all sprites with. Sorry? Oh yeah, we don't need the semicolon, but it's not a mistake. It's just the power of habit. Let's do it this way. It will be right. It will be faster, right? So I have my variable. I created here. I added to the scene. Now I can do stuff here with it. Instead of going to all touch events, I will do this. I will check if touches dot count more than 0. If I have any touch events, I will get the first one. Touches dot first. From this guy, I need a location. Location equals self dot sorry? Position in, oh. Self u dot location node or positioning node. One. No. Okay, let me go back to the documentation. You can always do that. Swift sprite kit location in node. Self, but touch. Touch dot location in node, and then we are saying which node. And the node is self, which is the whole scene. Right, so now we know where did we touch the screen. Now, since Let's stop for a minute on the question marks and exclamation marks. We did check that touches are not empty, right? So here it would be safe to say this, right? The touches.first exists, right? So unwrap it. And then whenever we will have to use touch, we won't have to use the question mark. And at the same time, everything that is produced from this, this object won't be optional, right? So our code will be a little bit easier. We can do that because we know that there is at least one touch in the set. So we know where we want to move our spaceship, right? How do we move it? How can we move nodes? We have to create action, right? So let action equal to sk action dot. What we want to do, we want to move. We don't want to move by. That's good for objects that are constantly moving in your update, right? You will be moving it by 5 points every update. We want to move to, and we have the location, right? You can move it to only along specific axis. We want to use this one. Now the location is our location. And the duration decides how quickly you want to move it. Let's say 2 seconds. We have our action, but that's not enough. We have to tell the node to play this action, right? So sprite dot run action. Now our ship will start to be alive. Here is broken.
That instruction.
You don't like spaceship. You can use car.
Did you inside did move to be able to keep this left sprite or just sprite?
Sorry?
Scroll to the top.
So this is my variable, right? I'm using it everywhere else. So everywhere is sprite.
That's interesting. It moves faster. How, like, depending on how far you go, that's just a piece of table there. 1 second.
You can try to do that.
No, it's already what it does. So if you click like really close to it, it goes.
Yeah, then it will go slowly. If you click very far, it goes quicker. Because what you're saying really is that the whole action has to complete within that time, right? Within 1 second, right? Now you can calculate this value based on the distance between your points if you want the constant movement, no matter what the distance is, right? Then you will give it more time when it's farther away and less time when it's really close, right? You can play with that. Since you have the current position and your destination, what you can do, you can also try to calculate if your sprite should rotate, right? You can add more cars and make a race. You can add also the background to your scene. Right, and here you can add, let road be equal to sk sprite node image named track. Right, you have to set the road position, and this position will be in the middle. Let's see how it will work. And self add child road. We have road. We could scale it. It will be, now, if you want to move your car constantly, right? So let's say I want my car to move in every update. It will be slowly going down, right? Then I will create action. Let move be equal to sk action dot move by cg vector x will be 0, y will be, let's move slowly, 1, and duration 1. Right, and then sprite dot run action I'm doing it in update, right? Now playing the game. I have my car locking up to the scene. Right? If you do -1, you have your car going forward, right? And then playing with the with the number here, and increase speed or decrease speed. Also playing with the duration, right? It seems it loaded the road on top of the car. That's funny. Let's check, because we create car first. We create road first. It should be on the bottom. Road, but, can always do this and set the position to -1 and make sure that it goes to the background.
How do you change the layer?
You can play with that position, right? The lower value, the farther in the background it is. Now, how to detect that our car is going out of the view? We have this object called frame, right? Self.frame. Let's see what we can learn from this object. Frame, you can check if it contains a certain point. You can divide it. You can get height. You can check what is the inset, and many other things. Basically, it's a rectangle that provides you with some information about what you see, because this frame really comes from the game scene, right? This is the rectangle that we can see. So, for example, if I want to check, say, if self-frame contains sprite dot position. Actually, if it does not contain, right? So with exclamation mark in the beginning. If it does not contain the sprite position, what we want to do, we may want to move it, right? So we want to set sprite dot position to be equal to new CG point. And this new CG point will be, well, X will be the same, right? So we'll get sprite dot, you can see it, position dot X, but the Y will be set based on our frame, right? So self dot frame dot max. Right. So when we go down to the bottom of the screen, below immediately will jump into the into top. Let's see if it works. Now let's say I don't want my car to go backwards, right? Even if I touch behind the car, I don't want it to go backwards. What I can do, I can ignore Y component from this location, right? And I can use move to X only. In this case, it will be location.x that I want to use. In touches began, right? Now, my car will be going left to right, even if I touch somewhere there, right? Now I'm moving my node, I'm moving my player. It's not, probably in this kind of game, it's not the most convenient way of doing stuff. Usually what you have, when you have this kind of game, right, you look from the top, your player has very limited way how it can move, right? Everything else is usually moving, right? So the background is scrolling, not your player, right? You can go within the your view. You can go up and down, left to right, but not necessarily farther than that. And right now we are kind of scrolling our player, right? Let's try to change this. Let's try to modify our code in a way that we can move the player, but let's try to give this this feeling that the road is, that we are going on the road, because road is right now static, right? That's not what we want to have. How can we do that? Definitely, I will have to declare a new variable, right? Var road sk node. I also don't like the fact that we are going from the top to the bottom. So let's try to change this as well. We start facing up. Am I right? I don't have to rotate at all. No. right. And then we'll go to the top, meaning our action in update going 5, +5, not -5. Yeah. But this is something that I will leave right now. Well, I will disable this code because what I want to do, I want to keep my player always within the scene. You know what? Before we do that, you're right. Let's make it mean it's going the other way from the bottom to the top. But that's not the effect that I want to have, right? I want to start in the middle. I don't want to move my car this way. I want to move the road, and I want to scroll it. So what do I really need? I need 2 of them, if you think about it. I cannot have one and just reposition. Well, I can try, but I know it won't work, right? Because if I do road, same way we did it before, right? Sorry, SK action, dot move by, right? Oh, I have this action actually here, right? So I don't need to create it. I can say road dot run action move, right? And we want road to move down. So it has to be minus, right? If we play it right now, it's moving, right? But it disappears at some point. So what do we have to do? Well, we would have to do the same thing that we did here, right? And reposition it. Road. Let's see how it will work. First, my car is going away. Oh, because I was copy pasting, right? Run action. Don't want to move the car, right? Okay. So now my car can move left, right? But you see that there is this empty space, right? In between. What do we need to do with that? How can I solve this issue? Exactly. Exactly. I need to have a second piece of the road. Or I can have array, right? Road dot append. The first one will start same way this one starts, right? The second one, let's copy. Where should be the second one? What should be the position of the second one? First one starts in the middle. Where should I place the second road, second piece of the road? How do I find it?
Road 0 dot free.
X is okay, right? They will be aligned on X. The question is about Y.
Road 0 position 1.
I have road 0. Dot.
Position dot 1.
Why it doesn't see the road 0 as a... Let's do this. Let position 1 be equal road 0 dot position. So this is the position of the first piece of the road, right? And it's in the middle of the rectangle that it creates. What else can I take from the SK node? I can take frame, right? I can get frame. So maybe instead of getting the position, we should work with the frame. Let's see. Let's create, let's say that will be the new position that we'll use here, right? This should be Y position. Y position. So we have frame, and from the frame we can take min and max. Let's take max Y. Would it work? Let's try. Sorry?
It's gonna fail.
failed.
Because update still looking for road, not index.
I see I have some errors.
Yeah,
Yeah, because road here is basically what I have to do. I have to do this for R in road. R, 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 and R. I have to move both of them with the same speed, right? So I can use the same action. Let's see.
that's weird.
It's weird, right? They're not aligned. And they're jumping.
Yeah.
So let's try to do it in a different way. What else we can do? We used frame. Frame doesn't really work. We can use the position of road 1, right? Road 1 dot position dot y. We can add something to it. Say frame height divided by 2. Would that work? It doesn't work. What else we can get from the road? We have position. Run action. We can get the scene that it belongs to. What else? We have scale. We were scaling it down. Does it change anything? We're using frame, right? Frame dot we're using max y. Oh, sorry, we're just using frame max y. right? For the second one, and it was looking weird because it's shifted somehow. Can it be that the scale is really messing it up? How can I check what is the value of max y in here? In debug, right? And I can check. So my y position is 802. Now, if I check view self, and I will check I will check my road, the first sprite, I should be able to see the position of this one. Where is the position? Node, SK node. Where is the information about position of this guy? Can I do it in a different way through the code? Sure I can, right? I can log, right? NS log. Position Y. Road 0 dot position Y. Now, where is my that's the position, right? Let's print both of them. Position 1 and position 2. And I will stop right after printing it so we can compare. Okay, running, and I have both values. So the position of the first piece of the road is 384. Position of the second, the one that we calculated, right? 802. And how do we calculate? We used max y for this. So it's not enough, right? We move to the top of the screen, really. Nothing else. we need to move it farther up to align it. How much? Probably half of the height of the road, I guess. That's my guess. So I have to add something here to get the proper value. Let's try road. First, let's stop it. Road 0 plus frame dot y. Will it work? No. It's even worse. Any other ideas? We have frame and we have position. Right? We have all this information from frame, like mean, max, and stuff. And we have position. If we move just one, if we're gonna move just one, so let's say, comment this for a minute. I will do if let r be equal to road dot first. So I'm moving just one of them right now. When does it jump? That's one of the problems that we have. Exactly. Right? So that's one thing. It doesn't go totally off the screen before jumping to the top. And then when it jumps, it also jumps into the middle, right? We need to work on that first, and then we'll have to figure it out how to glue the second one to it. So our constraint here really is not right. This one. Right? Because we are checking for the position, and the position is where? Position is in the middle of our sprite. Right? So we cannot simply get the position, but we have to do something else. Our point equals. We'll use point. We have to add something to this position. And half of the height of R, right? Plus, we should really use we should create new CG point X will be position X, and Y will be what? We want to get the top edge of the sprite, right? So it will be r dot position dot y plus, yeah, half of the height of this frame. And then when it is jumping up, right? Again, we cannot simply move to the max y. We should move to max y plus same thing, right? Let's see if it will improve the way how it works. Yeah, it improved. We don't see anything.
No problems.
And I think I know why. Our top edge, when we start, is outside of the frame. Let's see. If we comment out this piece, you should see it. See, we start above. What does it mean? We cannot use contain as our condition. Right? We cannot use contains. We have to use something else. We can check if our point dot y is less than self dot frame dot mean y. Let's see now. It's going. We are far behind the midpoint. And then started the new one. Better? Okay. So let's go back to the position. We have the position actually because we figured it out here, right? That's our position. That's our position where we should start. Right? X is the same in both cases, and Y is top of the screen plus the height of the second one, right? Let's see. Let's take this. Where do we position our second node? Y position. So the first one was positioned in the middle, right? CG rect mid Y. What we can do, we can take we know where it ends, right? We have this max Y. We have to add frame height divided by 2. Am I right? So it's top plus half. Let's see. Now it looks good. You see where they meet, right?
It's not consistent every time.
Yeah. The inconsistency that we have may be due to the fact that the texture that we are using is not exactly the same as the size of the screen, right? And then when we reposition it, we are using size of the screen as our baseline, right? So you can try to play with the numbers and figure it out. Either scale down to keep it exactly as the screen size, right? Or you have to make sure that the position, either the initial position where we start, or later when we move it, aligns with the top edge of the screen.
Yeah, there's a parallax scroll.
That's the thing. What we can try to do, another thing, because they're both set to -1, we can play with the Z position, and we should avoid this blinking when they move. You still see the edge, but you don't see them blink, right? When you're moving them, when you're drawing them. And this is, oh, still here, you can see that. Funny. And that's because the road is semi-transparent. The road has transparency in it. That's why we see this. Now, if we want to speed up, we can change how fast the road is moving. Now you can add some obstacles on the way, and you have a good start for the speeding game. Probably moving car a little bit to the bottom.
Get that up. I'll just take right there. Sorry. Again. Oh, it's done.
Something like that, and then you can avoid things. And any questions about today's topic? So you have basic components, right? You have game scene, you have nodes. You can add different kinds of nodes, right? You can add text using label nodes. You can add sprites. You can add different shapes using shape node. You can move them depending on what you want to move, right? Either background or your sprite. We'll talk about collisions next week and how you can detect collisions in this framework. But I think you notice the simplest one, right? The way with frames. If two frames overlap, there is a collision, right? If the frame contains point, there is a collision. So we can work with this if you don't have physics body. And we'll talk about physics body at the end. You will see that this game engine also contains fully functional physics engine. One last thing, if you want to add scene to your game, you have to simply create a new class. So add new file. In sources, you select Swift file. Welcome scene. Create. What do I need? You take a look here, at the top, you will see that we need sprite kit, right? Instead of foundation, sprite kit. class, welcome scene. Its super class will be SK scene. And then the function that we need always, we need to start with is did move to view, this one. Because this is the function that is called when the scene is displayed. This is our setup, right? Let's add let text node be equal to sk label node. You can use the font name. You can start with the text and use the default settings, right? Welcome. Text node position is equal to self dot frame dot cannot just take center, but I can do CG point self dot frame dot x and self dot frame dot mid y. That's my position. Self dot add child text node. Okay, so that's my scene. I can add some other things. I can add buttons, for example, and then on touch began, right? So using this function, using this function, I can make a transition to the next scene. So I can say if somebody did touch the screen anywhere, because this is the welcome screen, right? So if anybody did touch the screen, then I want to do self.view dot present the scene. Which one? The game scene. And then in transition, sk transition, I can say how I want to animate this transition. So for example, dot fade with duration or open, doors open, vertically with duration 2 seconds. Okay. Now, by default, my game scene is presented, right? I want to change that. I've saved this. Which class is really loading the initial scene? The view controller. This guy is loading game scene from this file. I don't want to load game scene from this file. I want to load it from, well, scene. And things that we didn't discuss. SKView has few options that help us with debugging. show FPS and show nodes, node count. This allows you to display on the bottom of your screen information how performance-wise you're doing, right? So how many frames per second your game is rendering, and how many nodes you have. This is important if you're creating and destroying nodes. You may want to see this, this number when you're debugging. And when you don't want to debug anymore, you want to see your actual game, then you can switch this flag to false. Hey, let's run. It didn't load the scene in correct way. Because I'm creating game scene. I want to create welcome scene. Sure, I don't have to do it in the if statement. Because if I create it like that, the previous one was also including the SKS file. I'm not using SKS file, so I don't need if statement here. Okay, I have my scene, tap. It's not working as it's supposed to be working. It's trying to do something. Because we didn't set the parameters. Okay. Another important parameter is the scale mode. And it tells how the scene adjusts to the size of the screen. Aspect fill seems to be most useful, but there are other options. You have aspect fit, and then it will try to use aspect ratio that is set in your, or keep the aspect ratio, but at the same time, it will fit into the size of the screen. And then fill and resize ignores the aspect ratio, right? So aspect fill is the one that we want to use. And this is something that is missing in our transition. If we go back to the welcomes screen, we are creating a new scene here. Let's do it in a proper way, right? Let's move it from here. Let scene equal to game scene. We want to add file game scene, because there is SKS file associated with our game. Sorry, with our game scene, and we want to show scene. Let's try now. And that's our game. So here we should set the for the text node, we should set the font size something bigger so we can see it. Still don't see it. Why we don't see it? This text font color Try to set color. Still not there. What am I missing? Sorry, I have the position. You can try to set text later. Text note. What is missing? Use font name, but that shouldn't be a problem. You should use a default one. Called Stir. That is the font name that was used. If I correctly remember. That should be exactly the same thing. Let's see. I will figure it out.
Can I see a touches began function in welcome screen?
Yes. We basically, in touches began in the welcome screen, we don't care where user is touching the screen. Just recognize that there was a touch and we go to the game, right?
It's just going to this instead.
Oh, it's because you're missing this.
No, it's there.
It's there?
Sorry. Commented out the other one.
Okay, let me stop this and stop the broadcast.